Okay, guys, this is an IGCSE video on acids, bases, and salts. And right before we start, we have got to define things. Acids. What are acids? Acids are proton donors, defined as proton donors. And bases are proton acceptors, and salts is what you get when an acid reacts. What you get uh, whenever an acid reacts. And we are going to talk about in detail. And what do we need to talk about? What in detail? An acid. Let's start with an acid. Right. So let's take, for an instance, an acid which is actually uh, let's look for this acid, hydrochloric acid, which has got two electrons that are shared. So we've got your acid, and this is obviously your H, and this is your Cl, and this is hydrogen chloride. It is hydrogen chloride if it is in gaseous state, so it is HCl gas. So it is hydrogen chloride. So if we take this hydrogen chloride and we put it into a beaker of water, so we put it into a beaker of water, what is going to happen essentially is this: your hydrogen and your chlorine are going to separate. Your hydrogen and your chlorine are going to separate. So this is your chlorine, and your hydrogen. So we have got your hydrogen and your chlorine. So what happens is that your chlorine will take both the bonding electrons, takes both the bonding electrons, and your hydrogen is left without any electrons. So what happens is that your chlorine is going to be negatively charged because it has got an extra electron, and your hydrogen is going to be positively charged. Hence, if you dissolve this in water, if you put this in water, this is going to be ionized. It is going to be ionized. It is going to be changed into ion, and therefore it means that it can be able to conduct electricity. Since it has got mobile electrons. Since it has got mobile electrons now, it has got mobile ions. Sorry, not electrons. Mobile ions. Now it can be able to conduct electricity. It's good to say that, interestingly, before you dissolved it in water, this thing was not ionic. It was actually covalent. And so it didn't conduct electricity. But as soon as you put it in water, it actually turned into ions. So these become what? Ions, as you can see, and ions can be able to conduct electricity. And what does that mean, therefore? It means that if you what has happened, we can actually say that an acid can be actually also defined as is when you dissolve substance in water, and it forms hydrogen ions. It forms hydrogen ions. That's another way of defining, an acid. So, what about the proton thing? Where does it come from? What about the proton thing? Why do we say proton? It is a proton donor. Why do we say that it is a proton donor? Where does the proton come from? So let's go back to our uh, hydrogen chloride. Let's go back to our hydrogen chloride. If you look at what we said there, we said that we have got this, that is the molecule that has happened, that we have there, and this is actually your hydrogen, and this is your chlorine. So if this dissociates, so we put it in water. So after we've put that in water, what happens is that your hydrogen will be left without electrons. Sorry about changing the color there. There's your hydrogen, and this is your chlorine. So what has happened is that your hydrogen is left without any electrons. I don't know what has happened here. For some reason it reduced size. So your hydrogen is going to be left without electrons. Okay. So what has happened is that your hydrogen is left without electrons. And remember that your hydrogen actually was like this. It had an electron here, right? So what happens is that the hydrogen has got an electron and it has got a proton there. It has one electron and one proton. So this is your hydrogen. So if you take away its only electron, the only electron that it has, this is going to be left. The proton is just going to be left. So that's the reason then this is just a proton. And this is the reason why it is called a proton donor. So this is what an acid gives out. It gives away, or it donates the proton, because the hydrogen ion, and the hydrogen ion is the same as saying that it is a proton. Okay, so it is actually, it should be made clear what we mean by saying that it is a, a, a proton. Okay, so let's go to base. Let's go to base. What is a base? Right? Okay. We have already said that a base is a proton acceptor. It is a proton acceptor, right? And it is important for us to know examples of a base. A base can be a metal oxide, a metal hydroxide, or a metal carbonate. And what is important to know is that, let's talk about this. Let's give an example. A metal oxide can be let's undo this, can be calcium oxide or sodium hydroxide. Right. What makes a base? What makes this a base is not the metal bit, it is actually the non-metal bit. And this is your non-metal bit, and your non-metal bit is actually this or this. Okay, so we said that it accepts a hydrogen ion or a proton. Remember that by saying hydrogen ion, we are saying the hydrogen proton, which is this, it accepts this proton. So you add a proton to this. And if you add a proton to this, it becomes a hydroxide ion. And if you add another proton to this, it will become water. Becomes water. So that's what happens. So and the same thing will happen to this if we uh, add a proton to it, right? And if we add a proton to it, it will become rather, let me just do it like this. If we add a proton to this, it turns to water. So it has changed to water. And this reaction is very important. It is called the reaction of neutralization. It is actually neutralization, as your water has got a pH of 7, as it is actually neutral. The thing that is formed is actually has got a pH of 7. Now, right. So the same thing with this. This is actually the same thing to say that it is also neutralization. So it is important for us to actually know that. So what is left behind? What is left behind? So the thing that is left behind is actually a salt. Remember, what has happened is that your acid, if you take your acid will donate a hydrogen, right? And that hydrogen, that proton is going to react with either an OH or an O2 ion or an oxygen ion, and in both cases you are going to form water, right? In both cases you are going to form water. So this has been accounted for. But remember that on your acid, for example, if you had an acid, you had hydrochloric acid, right? This reacts, this does not react. But in base, you've got a metal bit, right? So the metal bit also does not react. So what has happened is that this has not been accounted for, and this has not been accounted for. So what happens is that these come together. When they come together, they form a salt. So what are we saying? We are saying the thing that is left behind, what is left behind is the salt, right? So we get a salt. So let's give a proper example. So how do we form a salt? A salt can be formed in different ways. Let's take so if a salt, let's use equations. When a metal reacts with an acid, you are going to get salt and hydrogen, salt and hydrogen, hydrogen. So let's give an example, which can be magnesium plus hydrochloric acid, right? Obviously we need to put, this is aqueous, this is salt, this is a solid, so we get magnesium chloride plus hydrogen, right? We need to balance this, and this will look like this, right? And obviously what you need to be able to know is that this is a reaction. So what has happened, this